All right, so in this video, we're going to talk about how to run a dependent t-test. And a dependent t-test is just testing to see if there is a significant difference in a before and after situation. So here we're talking about having a drug trial to help people's cholesterol. So we're going to test to see if there's an average difference among cholesterol levels in patients A through H with our new drug. So remember that we are testing if there is an average difference or not. The numbers are different, literally, but we have to see if there's a significant enough difference for us to claim that our drug is effective or not. So the null hypothesis is always that the mean is equal to 0, that the mean difference is equal to 0. So the null hypothesis is that nothing happened. Okay, so our new cholesterol pill accomplishes nothing, basically, is the null. And then we're going to run the t-test to see if I reject the null or fail to reject the null. So we just said this, but this is going to be a dependent or paired t-test because we have two samples of data that each belong to the same patient. A one sample t-test is just, it's literally one sample of data, but here we have two. So the first thing we're going to have to do when running a dependent t-test is find the average difference among the numbers. And then UT, remember, will always tell me which way to subtract. So they say we want to subtract after the drug trial minus before the drug trial. So we're going to do after minus before. So we're going to do like 197 minus 279. Okay, and I like to write this down. I'm not going to write it for time's sake, but I would like to write down the differences right here in an extra column. And that way I can keep track of what's going on. So like if we were going to write it down, I'll write down one of them. We would say that's negative 82. And then the next one we would say that's negative 43, and then we would just keep going. Okay? To save some time, so this isn't a 2-hour video for y'all, we are going to find the mean and standard deviation in the calculator, actually. So you may not have your calculator if you're watching this at home, but if you have a TI-84, mine's going to look a little funny because it's a computer version, but if you have a TI-84, to find mean and standard deviation, we're going to press stat, and it's going to take us, this is our screen over here, so it's going to take us to our screen, and then we're going to press enter, and that's going to take us to a spreadsheet. Now, it takes me forever to type on this computer calculator, so I've already typed in all the numbers, but these numbers you see right here are the differences of these numbers. So 197 minus 279 was negative 82. That's where these numbers came from, is I just subtracted after minus before for every patient, and I only typed in the differences into the calculator. I didn't type before and after. I only typed the differences into this first column. So then after we type in our differences, and if you're following along, just pause it and type these in. But we type in our differences into L1, and then we go to stat. Then we go over to calculate. So now we're on calc right here. And then we just want one variable stats. Won't go over all this other stuff later, but for now, we just want one variable stats. So we're just going to press enter 4 times. Don't mess with any of this stuff. So we go down to calculate and press enter. And then it's going to give me a couple relevant pieces of information. The mean is negative 77. So the mean is negative 77. That's X bar right here. That's the mean. And then SX is our standard deviation. So the standard deviation, I would write these down because the screen's about to go away. But the mean is negative 77. Standard deviation is 49.785. I normally just keep 3 decimals. It won't be all right if we do that. And then I'm going to go ahead and write down sample size because we'll need that for degrees of freedom later. Okay. So we're going to write down X bar, or mean, is negative 77. We're going to write down that SX is 49.785. That's my standard deviation. And then we're going to write down N equals 8 because that's my sample size. Okay. So then we're going to minimize. And the question asks me, what is the average value? What is the value of the average difference? So that's the mean of the differences, which is the only mean we're doing. So that, oh, my number lock is on. So that's the mean that we calculated from the calculator, which is negative 77. Okay. The standard deviation, again, we also got from the calculator. So it's 49.785. That was SX when we just did the stat edit process. Standard error, if we remember, I'll write this on the screen. So standard error, I'm going to zoom in a little bit. Standard error is, so standard error is the standard deviation divided by the square root of sample size. Okay? So I know, oh wait, I'm writing in the wrong spot. So standard error, the standard deviation we found to be 49.785. Can y'all read that? 49.785. And then we divide that by the square root of sample size, which is n, which is why I wrote that down earlier. So it's 49.785 divided by the square root of 8. Okay. Which I should. I'm just going to use the calculator on my hand. Y'all can use your calculator to follow along with me, but. And that is 17.602. Okay, so I just divided this in my calculator, and I got 17.602. Okay, so now we'll scroll down, and let me get rid of that. Okay, the test statistic is next. So the test statistic is t equals the sample mean minus the null divided by standard error. Okay, so the sample mean we found to be negative 77. The null, we wrote this in the notes, but the null is always 0 for our purposes of a dependent t-test. So the sample mean was negative 77, and then the null is always 0. I wrote minus 0. You obviously don't have to write that because it doesn't do anything mathematically. And then the standard error, we already found this on number 4. Okay, so that's 17.602 that we found in number 4 is standard error. Okay, so we found the standard error, we have the sample mean, we divide those, and we come up with a test statistic of negative 4.375. So negative 4.375 is my test statistic. And then I should have had this pulled up. Let me pull up a t-table for us. Oh, get all that writing off the screen. So if we ever need a t-table, it's right here in course resources. And remember, for our t-table here, we are always going to be 95% confident. So we are always going to be looking in this column right here. And that makes it hard to read, huh? But we're always going to be the 95% column. And then degrees of freedom right here is always going to be sample size minus 1. So if you remember, we had, at the very beginning, we had 8 patients. So my sample size is 8. Okay. So since we had 8 patients, my sample size is 8. So if I have 8 as my sample size, my degrees of freedom is 7. So we're looking at 7 degrees of freedom, and then we are 95% confident. So our T critical is 2.365. Okay. So we're going to go back and we're going to put 2.365 in for my value of T critical. Okay. Because again, we found that by doing degrees of freedom is 7, and then we're 95% confident. Okay. Oops. That was a highlighter, not an eraser. Okay. Now we have to figure out if we reject or fail to reject. Okay. So I'm going to draw our picture. So we have our T critical was 2.365 and negative 2.365. And we have our critical region, our shaded region on each side. And then we're testing to see if the test statistic is between our critical values or outside. And if you remember, our test statistic was negative 4.375. Okay, so we're seeing if negative 4.375 is between my critical values or outside. So negative 4.375 is outside or more negative than negative 2.3. So it is in the critical region. So I reject the null. Remember that if we are in the critical region, we reject the null. And if we are in between the critical values, that's just the not critical region. It doesn't have a fancy name. We fail to reject when we're between. We reject if we are outside on either extreme. So since the test statistic of negative 4.37 did fall into the critical region, we reject the null hypothesis. Therefore, my new drug did have a statistically significant impact on cholesterol. Remember that the null is that no difference occurs. Okay, so if we reject the null, we did find a difference. This conclusion right here, this 2 sentences, that will be our short answer on exam 4. So we need to be able to write this sentence come test day on exam 4. You can always format it like this. You're just not always going to be talking about cholesterol drugs. But it will always be formatted. You did or did not fall into the critical region, so you reject or fail to reject the null hypothesis. Therefore, you did or did not find a statistically significant difference in your results. Okay, the last thing I want to show you is a confidence interval. So I'll do this lower and upper bound, and then y'all can do this second practice problem. Oh, my pen died. Oh. Okay, so first we have to find margin of error. So if we remember, our confidence interval is the sample mean plus or minus T critical times standard error. So this is an old formula that just keeps popping up. This right here is the margin of error. Okay, so we have our sample mean, which was negative 77, plus or minus T critical, which we found to be 2.365, times standard error, which we found to be 17.602. We found that right here, and we have T critical right there. That's where those numbers came from. And then the sample mean we found back way at the beginning of the video. So we put everything where it goes. Technically, how this question is structured down here with the margin of error, oops, too far, with the margin of error being right here, we want to multiply. We want to find this multiplication first. So I'm going to multiply 2.365 times 17.602. And that gives me negative 77. Oh, I'm writing with the highlighter. Hold on. Negative 77 plus or minus 41.629. And the margin of error here is the 41.629. And again, I found that by multiplying those together. The lower bound and upper bound, if you see, we have a plus and minus right here. So the lower bound is just what do we get when we do our plus or minus. So negative 77 minus 41.629. So if we do negative 77 minus 41.629, we get negative 118.629. And if we do negative 7 plus 41.629, we get negative 35.371. So my lower bound is when I subtract, and my upper bound is when I add. So my lower bound is going to be the negative 118.629, and my upper bound is going to be negative 35.371. Okay? So that's how we do our confidence interval. It is always sample mean plus or minus our margin of error. Just going to leave that info here for the numbers for reference. Because the last question is, I think the second short answer on exam 4 is going to be writing the conclusion to a confidence interval. So the first short answer is going to be the conclusion to a dependent t-test. I think the second short answer will be a conclusion to a confidence interval. So I just want to remind you of the sentence for confidence interval. So this says, based on the confidence interval constructed above, we are 95% confident that the new drug trial made an average difference of between negative 118. It's just these numbers right here. I don't know why I didn't put the decimal as an answer, but negative 118 and negative 35. Okay? So again, we need to be able to write this confidence interval sentence by ourselves on the exam, and we need to be able to write the t-test conclusion by ourselves as well. All right. I hope that helped, and then y'all can come ask me questions if you need more.